So good afternoon, good night, or perhaps even good morning. I'm Dr. Franklin, and I'm presenting to you a tutorial on how to go about calculating a standard deviation. So I'll try to be as succinct as possible so that you can get the information in a rather quick way so that you can go about completing whatever problems you have or whatever homework assignments you have, or maybe it's related to some research. You're trying to calculate a standard deviation. This tutorial video will certainly help you with that. So the reason why we're talking about a standard deviation is because it's important to know what it means and how to go about calculating it if you're trying to get an understanding of the variation that's occurring in your data set. So two of the measures of variability that we've talked about in our class are the range and the standard deviation. And we talked about some limitations that the range has. In particular, one of those limitations is that the lowest score is simply being subtracted from the highest score. Okay, so with the current data set that we have right now with 81515, all that's occurring is that 1 is being subtracted from 8, telling us that the range in terms of our particular sample is 7. Okay, which is fine and dandy, but perhaps we wanted to know the average distance that all of these scores are from the mean. All right, and perhaps we wanted to get a better estimate of, the particular distance that all of these scores are from the mean with the consideration of every single score, because again, that range only takes into consideration two scores, that highest score and that lowest score. Okay, calculating the standard deviation will help you in being able to assess that variability within your particular data set. So let's start by just writing out the formula for the standard deviation. So that's simply S, and this means sample standard deviation. Just sigma parentheses x minus sample mean squared over n minus 1. All right, then we put a big old square root sign over top of it. Okay, so that's for the sample standard deviation. That's a lowercase s, which stands for the sample standard deviation. Sigma stands for sum, x stands for raw score, capital M stands for the sample mean, and then this n minus 1 is the degree of freedom that's in the denominator. Okay. And then this is the formula for a population standard deviation. Capital N. And there's a square root over that. Okay, so we have a sigma, we have a raw score, we have a population mean, we have it being squared, and then we have the population total right there. Okay, so we're going to say that this is a sample, and thus we're going to be utilizing this particular formula. Okay, so we're going to use this formula for calculating our sample standard deviation. Now, the only real difference between these two formulas is that one is for a sample, one is for a population. Okay, in this formula there's n minus 1, which is the degree of freedom, and in this formula, in the denominator is capital N, which stands for the total population. Okay, so that's the only major difference between these two formulas. Okay, so based on what type of data set you're working with, you're going to want to make sure that you go with the right equation when you're solving it. All right, so the first thing that we want to do when calculating our standard deviation, if it's not given to us already, is calculate the mean. Okay, so the mean is simply adding all of these up and dividing by the total sample size. Okay. So 8 plus 1 plus 5, that would give us 14, 15, 20, right? So we got 20 over 1, 2, 3, 4, 5 scores. Getting our sample mean. So 20 divided by 5 will give us 4, okay? So that is our sample mean for this particular sample, okay? We have a sample mean of 4. From there, what we're going to do is calculate our deviation scores. Okay? So we got x minus sample mean of n. So I would suggest making a column like that. Okay. So we have 8 minus 4, 1 minus 4, 5 minus 4, 1 minus 4, and 5 minus 4. Okay. So 8 minus 4 is 4. 1 minus 4 is negative 3. 5 minus 4 is 1. 1 minus 4 is negative 3 again. And 5 minus 4 is 1. Okay. So we could say that the first step that we did was calculate sample mean. Okay, if it's not already given to us. So I'll put a little asterisk right there. Next thing that we did was we calculated our deviation scores. Okay, so we're seeing how far each particular raw score is from the sample mean by subtracting the sample mean from a particular raw score. And that gave us all of our deviation scores. Okay. Next thing that we want to do is square those deviation scores. Okay, so 4 squared is 16. Negative 3 squared is 9. 1 squared is 1. Negative 3 squared is 9. 1 squared is 1. Okay. So the reason why we're doing this is because if we were to add up all of these deviation scores and then try to divide by the sample size, we wouldn't get very far, because once we added up all these deviation scores, they're going to be 0. That's going to be our final answer. Negative 3 plus negative 3 is negative 6. And we got 4 plus 1 plus 1, which is 6. If we add both of those up, 6 plus negative 6, that's going to give us a 0. So what we need to do is square all of these scores like we did here, so that we would avoid that problem, because ultimately we want the average distance that all these scores are from the sample mean. Okay, so third step was calculate squared deviation scores. Okay. So going back to our formula, what are we doing? Well, we're following the order of operations as it pertains to this formula, right? So first we needed to get a sample mean in order to do a deviation. Then get into our order of operations. We're taking care of what's in parentheses first, right? Sample mean minus a raw score. Do that for every single raw score. Okay, that's what we did here. Then from there, we decided to square our deviation scores. So parentheses, exponents. Now we're taking care of that square. So we've squared all of our deviation scores. From here, we're going to sum up all of these squared deviation scores and get something called the sum of squares. So the sum of squares is the sum of all your squared deviation scores. So 16 plus 9 plus 1 plus 9 plus 1. Okay. So 9 plus 1 plus 1 plus 9 plus 1 will give you 20. And then 20 plus 16 will give you 36. Okay. So calculate sum of squares. Okay. And that's what we just did right there. All right, so the next step is to calculate our variance. Okay, and this is the symbol for variance. And variance is the average square distance that all of these raw scores are from the sample mean. But we don't want the average square distance that all these raw scores are from the sample mean. What we want is the average distance that all these scores are from the sample mean. Nevertheless, we have to calculate the variance first. It's a precursor to eventually getting to the calculation of the standard deviation. So, how do we go about doing that? Well, going back to our formula, we've got the sum of squares, or everything that's in the numerator, right? That's the sum of square deviation scores. We simply divide that sum of squares by the degrees of freedom, or that n minus 1. Okay? So we bring that 36 down because it's our sum of squares. We're going to divide it by n minus 1. And if you recall, we have how many numbers in our data set? So we got 5 numbers in our data set, right? So 5 minus 1 will give us 4. Okay. So 36 divided by 4 will give you 9. All right? So that's the variance. And then lastly, we want to, let me go ahead and jot this down for you guys. So calculate variance. Lastly, we ultimately want to get our standard deviation. So what we need to do is take the square root of that 9. Okay, so if you see our formula, we worked our way through everything in the numerator. Eventually divided the entire numerator by the denominator. Now that we're done with that and we have the variance, in order to get the standard deviation, we have to take the square root of all that. So if we take the square root of 9, that's going to give us 3 for our standard deviation. So calculate standard deviation. You guys can't see that. There you go. Calculate standard deviation. Take square root of variance. All right, and we can put in parentheses here. Divide variance. Divide sum of squares by n minus 1. Okay, so our final answer is 3. That's our standard deviation. So what does that mean? That means that on average, all of these scores are 3 points away from the sample mean of 4. Okay, so that's the variation that we have in this data set. All right, so one last recap again. We calculated a sample standard deviation. Sample standard deviation is demarcated by this symbol, which is S, lowercase s. S equals square root of sigma, there's parentheses, x minus capital M, with the exponent outside of it, with n minus 1 in the denominator. And this is the formula for a sample standard deviation. This is the formula for a population standard deviation, the main differentiator being what's in the denominators and also the different types of means that are used. So this is a population mean, whereas this means sample mean. Okay, we decided that this was a sample, so we went with this. Okay, now from there we were off to the races, just simply following our order of operations. So the first thing that we needed to do is to take care of everything in parentheses, then exponents, then take care of that addition, take care of that division, and then eventually take care of that square root. So following our order of operations led us through these steps. First, we calculated the sample mean, if we didn't already have it. Then from there, we took the sample mean away from every single raw score that we had. Okay, and we created a column with x minus capital M at the header. Then we squared those deviation scores here. Okay. Then we added up all of the answers to get our sum of squares. Okay. After we did that, we subtracted the sum. We divided the sum of squares by n minus 1. And then finally, we took the square root of the variance. Okay. So that concludes this video. I hope that this was helpful. Please feel free to share this with different people that you think could use the assistance. And by all means, leave comments. Let me know if it's been helpful. I'll see you soon.